Okay, year 11. Right, we're going to start our next topic now. It should be a nice, easy, quick topic. Shouldn't be anything too difficult. There is a little bit of note-taking I'm going to need you to do throughout this, so please make sure you've got a pen and paper ready. There are some key terms that you need to know about. It's a little bit more wordy, this bit of work, but it shouldn't be too bad. The bits we are looking at today is we've got to do some critiquing of sampling and look at some random samples. So it's all about sampling, it's all about data collection and that sort of thing. So quite a lot of it is quite common sense anyway. A few key terms I need you to know about first. So the first one is population. Okay, now the population is every item or every person that possibly involved in an investigation. So if I wanted to know the favourite colours of students in year 11, the population would be everyone in year 11. Okay, now if we switch that and instead think of a sample, so a sample is a small selection of the population. Now, to avoid bias, the sample we use should represent the characteristics of the whole population, and therefore we can use the results from our sample to make conclusions for the whole population. Okay, now we tend to use a sample when trying to use the whole population is inappropriate. So, for example, if you were thinking about doing something school-wide, you wouldn't want to ask the whole population, so ask the whole school. You would take a sample instead and use that. Okay. Another example, if I want to work out the favourite colours of year 11, rather than asking all 200 students in year 11, I could take a sample just using our class. Okay, so the 30 people in our class use that as a sample instead, and then use that to make conclusions for the whole population. The last key term you may need to know about, okay, a census. A census is an investigation that does use every member of the population. So a sample uses a small amount of the population, as representative as we can. Okay, by representative we mean it's an equal, it's a fair amount of each group, whereas a census would use every member of the population. Okay, now we need to do some critiquing of samples. The first thing we're going to look at is random sampling. Okay, now random sampling, there's a posh definition there. In simple terms, all it is every person or item in the population has an equal chance of being chosen. And that's the really, really key bit, okay? Equal chance of being chosen. Okay, so if we use the example of year 11, okay, my sample, if I wanted a sample of 11x, that's not very fair because no one else outside of 11x would have a chance of being chosen. Okay, so that would not count as a random sample. The reasons why we randomly sample, and we should always randomly sample, okay, it's the best way to get representative set of results. So again, I'm going to highlight that. That's our two really important keywords. So it's the best way to get a representative set of results. It also reduces the likelihood of bias. Okay, now bias is really important when it comes to sampling because it is very easy to become biased without realising it. That's why we try and use random samples instead. Okay, now the first thing I want us to do, or be able to do, is to critique samples, so make comments on them, okay, and why they would or would not be appropriate. So I'll give you some examples, then there's a few for you to have a go at. So, first of all, the first one asked 10 of his friends what they thought about a new video game. Is this sample of students in the school biased? Well, he's only asking his friends. Because he's only asking his friends, okay, does everyone have an opportunity to be chosen? No, they don't, because he's only asking his friends, therefore it's a very, very particular sample size. Therefore, no, it isn't going to be a fair sample of the school, okay, because he's only asking his friends. If you're only asking friends, then that's not representative. And again, it's that key word of representative. Okay. Second one, Brittany polled the first 47 bus riders at school. Is this sample of the student population biased? Now, if she's only asking people who got the bus, Does that mean everyone in that population has an equal chance? Okay, no, it won't. It will mean they won't, because if you walk to school or you come with your parents to school, you would not get the opportunity to be asked about it. So again, it's not fully representative of the whole population, because again, the whole population is all the students. The whole population is the school. The same as with the first one, because it's of the school, it is not a fair sample because not everyone has an equal chance to be picked. Jake surveyed the fastest 7 runners in PE about their favourite class. Now, it could be that this is unbiased, okay, and it could be that it works as a random sample anyway. The only issue you've got with this, if you're thinking about the 7 fastest runners, it's a bit like asking, for example, the 7 best mathematicians what their favourite class is. The chances are they might well be biased, okay, because that may well be their favourite subject. So for all that could possibly be a better sample, because you're only asking the fastest runners in PE, is that going to be biased? Now, I would worry, is that going to be biased towards PE? Okay, because you're asking the top students from that subject, and only the top students. The next one, Mr. Johnson looked at 3 different problems from each test given last year. Each test had the same number of problems. Is this sample of the test problems assigned likely to be biased? Now, what he's done, okay, he's looked at every test, okay, so he looked at each test, and he selected 3 different problems. Therefore, you would hope that this is going to be a much better sample. He's taken 3 from each test, so he's going to be doing representative of all the tests, okay, and he's picked 3 from both. So at the moment, that definitely looks like the best type of sampling that we've got so far. The last one, a survey was conducted of 13 shoppers who spent the most at the mall last month. Is this sample of shoppers at the mall likely to be biased? So we're asking people when they went shopping. So a survey was conducted of 13 shoppers who spent the most at the mall last month. Is this sample of shoppers at the mall likely to be biased? Well, if it's the 13 shoppers who spent the most, okay, then it's going to be probably a good sample to be looking at, in the sense of they're going to have lots of opinions about the mall. But because they shop there a lot, their opinion might well be biased to being more positive. So again, we need to be really, really careful about how we select our random sample. What I want you to do now, okay, obviously there are quite a few different ways of answering these. I want you to have a go at the first worksheet that's on Show My Homework, the one that talks about criticising samples. Have a go at it, come up with some ideas, and then have a look at the answers and see if we can match up what we've got. Okay, so pause the video now. I want you to have a go at that worksheet, have a think about it, write some ideas down, and have a look at the answers. Okay, so the next bit that I want to do today, taking a random sample. Okay, now we want to make sure we are doing as fair a sample as possible, so it gives everyone that equal opportunity. That's the key part of this, is making sure that every person has an equal opportunity to be picked. Okay, now in order to take a random sample, we have got 4 steps that we need to go through. What we try and do is we assign each person in the population a number from 1 to however many there are. Okay, so for example, in our class it would be 1 to 29. Okay, every person gets a number. So for example, Mary, James, Jack, Sean, whoever, you would number 1, 2, 3, 4, and so on. Okay. What we then need to do is generate a list of random numbers, and they have to be random numbers. They can't be ask someone for a number and take that one. Okay, they have to be completely random, and there are a few different ways we can do this. We can use a random number table, which is how we are going to do it for your studies. You've got pulling numbers from a hat. You've got using something like a lottery machine, rolling a dice, What you can also do is there's a random function on your calculator. There's quite a few different ways we can go about doing this, but we have to make sure that they do come up with random numbers. We then use our random numbers, however they came about, to select the corresponding person from our population. Because the numbers are random and because those numbers are all assigned to people, this would mean that everyone has an equal chance of being chosen. Okay, therefore we will have a perfectly random sample. All you keep doing is continue working through your random numbers until you have selected enough people that you wanted for your sample. So if you wanted 10 people, you would go through until you'd used 10 random numbers and selected your 10 people. Okay, now I'm going to give you an example of how we do this, and then we'll get you to have a go at some. So here's our example. In a class, there are 30 people. The teacher decides to take a random sample of 5 pupils to estimate the mean height of the pupils in the class. Select a random sample of 5 from the list. Now you can see on the right hand side, I've got the 30 names of all my students and I've numbered them all 1 to 30. Okay, it doesn't matter how you number them, you can number them however you want to, much easier just to do them in order. Then at the bottom, we've got a random number table. Now these are just randomly generated numbers in any order. And what we can do is we can use these now to help us choose our students. Now, what you have to be careful with our random number table is how you isolate your amounts. Now, because we are working from 1 to 30, that means I need to make sure I've got enough for a 2-digit number. So I need to siphon my random number table off into 2 digits at a time. If it was, for example, 1 to 400, I would need to take off 3 digits at a time. Okay. If it was only 1 to 9, I only need 1 digit, and so on. What I'll do is I'll use my number table, and I'm going to split now all of these into 2-digit sections. So these are all split off into my 2-digit sections for me to now use. And all I do is I look at my first 2-digit section and see who that picks up to. Now I've got 34. Now I don't have anyone represented by number 34, so I just ignore that random number. Okay, I don't find the nearest one to it, I just ignore it and I move on to the next one. Again, 54, haven't got one. 73, not got one. Right, 07, so number 7. Therefore, because that one works, I'm going to take number 7 out, which in this case is Matthew. So my first person selected will be Matthew. And I keep going through. 71 doesn't correspond to anyone, neither does 40. 26 will do. So I take 26, which is Helen. So Helen will be my next person in my sample. Oh, 05, so I can have 5 as well. So Jane will be in my sample. 88 doesn't, 85 doesn't, 66 doesn't, 45 doesn't, 57 doesn't, 60 doesn't, 27 will. So I'll take Fatima. '82 won't, 76 won't, 15 will. Therefore, I'll take Miles as well. And that's how we begin to use our random number table. Once we've assigned everyone in our population, okay, a number to generate each one. Now, the issue with this is it can be quite time consuming. Okay, obviously we've wasted quite a few as well, so you might need to make more random numbers, okay, or use a bigger random number table. But what it does do is those 30 people in that class all had the exact same chance of being selected. The big bit you got to make sure is that you split your random number table into enough digits, depending on how many you need. And then we just work our way through until we've got enough. The worksheet I want you to complete is on Show My Homework. Please get that completed, get it marked and get it uploaded.